solve some systems of equations in 3 variables rather than 2. I'd like to tell you this is pretty straightforward. It's one step, but it's not. There's multiple steps, and you want to be very careful in each step that you watch your multiplication, division, addition, subtraction, because one little sign change can cause lots of havoc. Our goal as we start this is to get down to what we're more familiar with, 2 equations with 2 variables. So what we want to do is use a combination of work over here to eliminate one of the variables, okay? So you choose a variable you would like to eliminate. Let's say I want to eliminate x, okay? So if I wanted to eliminate x using the first and second equations, notice the second equation has a 6, so the first equation would need to have -6, so that when I add those, the x's would be 0. So I'm going to take this top equation, and I'm going to multiply it by -6. And then I will add it to the second equation. Okay? So when I do that, I get -6x minus 6y minus 6z. I'm going to put a slash through my z so I don't mistake them for 2. Equals -12. Don't forget that number on the end. Okay, the second equation, I don't have to do any work with it. I'm just going to write it down here so that I can add them. Okay, when I do that, just like I planned, 6 and -6 gives me 0 x's here. -6 and -4y gives me a -10y when I add those, and a -6z plus a 5z gives me a -10z, excuse me, not 0, and -12 plus 31 is 19. That gives me one equation with 2 variables. I need another one. So I go back to the drawing board over here, and I want to use another combination of equations. I can't use the same 2, okay, to eliminate x's. So let's say this time instead I use the top equation and the bottom equation, the first and the third. Well, the bottom equation has a 5x here, so that top one I'm going to need to make that to have a -5, so the x's will cancel. So I'm going to take this top equation times -5 and add it to the bottom equation. I'm going to do that over here. So again, I'm going to do -5 times that first one. Okay, let's see what that does for me. That gives me a -5x minus a 5y minus a 5z is equal to -10, and I add it to my second equation, or excuse me, my bottom equation, so that my x's will cancel. Okay, we add those. -5 and +5x is 0 x's. Good thing, that's what I wanted. -5y and 2y gives me a -3y. -5z and 2z gives me a -3z. And finally, -10 and +13 gives me a +3. So now I have what I wanted. I have 2 equations with just 2 variables, and we're used to solving these, so it's not quite such a headache. Okay? So now I have -10y, my result from the first trial, and minus z equals 19, and -3y minus 3z equals 3, my result from my second trial there. Now, completely eliminate a variable. I'm going to choose 2 to go. You have to solve for x and y. Well, to solve for y, I can take either of these equations where I just had 2 variables. You don't want to go clear back to the beginning, because then you'll have only one of the 3. So go back to these where we had 2 equations with 2 variables. You can choose to use either of those to find out what z is. So let's say I chose to use this first one I found, where -10y minus z equals 19. Now my y was -2, so if I substitute that in there, I have -10 times -2 minus b is 19. Negative 10 times negative 2 is 20. And let's go ahead and solve that. Negative z is negative 1, or z equals 1. All right, we've solved for two of the variables. Now we go back to the very beginning, get one of these equations that has all three in it, and solve for x. So I'm going to pick this top one. I'm going to write it down here. X plus y plus z is equal to 2. We substitute those two values we know. We have x plus y was negative 2 plus z was 1 equals 2, and solve for x. So if we put negative 2 plus 1, we get negative 1. X minus 1 equals 2. And lastly, add 1 to both sides, and we get that x is equal to 3. We have our three solutions. We want to write them as an ordered triple, x, y, z, alphabetically. So x was 3, y was negative 2, and z was 1. That is the solution to this system of equations, and you can check your answer by putting those into each of these. It has to work for all three, and you'll see that it is indeed a solution. It works for all three of those equations to get valid answers. All right, let's try this again. So again, our first goal is to get two equations with two variables. So we pick a variable we would like to eliminate. Let's say I'm just going to pick x again because it looks to me like x would be fairly easy to eliminate since it's 1x in that top equation. So if we take the top equation and the second equation and we want to eliminate x, what do we have to do? We have a 2x. We need negative 2x on that first one. Okay? So I'm going to take this top equation times negative 2, which would give me negative 2x minus 12y minus 6z equals negative 8. Don't miss any of those parts. You want to multiply everything by negative 2. Okay, now let's write down our second equation. We're not going to change it at all. It didn't need anything to be changed. And add them to eliminate the x's. X's cancel, they get 0x. Our y's, negative 12 plus 1 is a negative 11y. Our z's, 6 minus 2, negative 6 plus 2 gives me negative 4z. And finally, negative 8 plus 3 gives me a negative 5. Okay, so we have one equation that just has y and z. So we want to go back to our original and find some way to eliminate x using a different pair of equations. Well, this time I'm going to use the top one, again, because it's a 1x. That makes it easier to work with. And the bottom one. Well, the bottom one has a 3x. So if I want to eliminate x's, I need this top one to have negative 3. So I'm going to multiply the top equation by negative 3 and then add it to the bottom one. If I multiply that top one by negative 3, I get negative 3x minus 18y minus 9z equals negative 12. And I'm going to add it to that second equation, that bottom equation, which was 3x minus 2y plus z equals 0. Just like we planned on purpose, the negative 3x and the positive 3x cancel to be 0 x's. Negative 18y minus 2y gives me negative 20y. Negative 9 plus 1z is negative 8z equals negative 12 plus 0 is negative 12. Now I have a system of equations with just two variables. So I have negative y minus 4z equals negative 5. That's the first one we found. And negative 20y minus 8z equals negative 12. I want somehow to cancel one of these variables. And y would be somewhat difficult because to get negative 11 and negative 20 to be equivalent, we'd have to multiply both equations by something. But notice we can easily make a 4 equal an 8. We just have to multiply by 2. And in this case, we're going to multiply by negative 2 because we want our signs to be opposite. So my plan is to multiply that first equation by negative 2, and then I'll add the two equations together. Okay, so then I'm multiplying this top one by negative 2. Okay, I'm going to write the result right next to it here. That would give me a positive 22y plus 8z equals positive 10. I'm adding it to that second equation, negative 20y minus 8z equals negative 12. Just like we had planned out, the 8z and the negative 8z give us 0. For our y's, 22 and a negative 20 gives me a 2y. And for the constants over here on the right-hand side, 10 minus 2, 12, gives me a negative 2. All I have to do now is divide both sides by 2, and I get that y is negative 1. We have solved for one variable. Let's go back to one of those. You can use either this equation or this equation, either one that has just the two variables in it. And we'll substitute our known value. I'm going to use this bottom one down here because it's easier to access without rewriting things. I know that now that y is negative 1. So here I have negative 20 times negative 1 minus 8z is negative 12, which gives me 20 minus 8z is negative 12, and I'm going to solve that for z. So I'm going to subtract 20 from both sides. I get negative 8z equals negative 32. If I divide both sides by negative 8, I have my second variable. Z is a positive 4. We can take both of those back to our very original problem where we have three variables. I'm going to use that top one, x plus 6y plus 3z equals 4. And I'm going to substitute those two values that I know. I know that y is negative 1, and I know that z is 4. So we'll have x plus 6 times negative 1 plus 3 times 4 equals 4. We have x minus 6 plus 12 equals 4, and we solve from there. This gives us x plus 6 equals 4. We subtract 6 from both sides, and we get x is equal to negative 2. Okay, so there you have it. We have x is negative 2, y is negative 1, and z is 4. Write that as an ordered triple. Remember to go x, y, z. All right, we're going to do two more. They look a little different, okay? So if you're thinking, I got this, no need to worry. These do look a little bit different. Okay, so notice here we do have a different, these second equations only have, well, they all three only have two variables in them. So what we need to do is combine them to somehow get just x and y, just y and z, okay? So you want to look and just choose. It doesn't really matter, just make a choice. Let's say that I like having just y and z, or I just like having x and y, okay? Whatever you choose. I'm going to pretend that I just want to have y and z, so I'm going to write this one over here to preserve it. I'm going to use that. 4y minus z equals negative 10. Then what I need to do is look at these top two equations and say, what do I need to do to get rid of the x's so that all I'll have left is a y and a z? Okay, well, to eliminate the x values, I have a positive 3x on my first equation. So that second equation, I'm going to need a negative 3. So I'm going to take the second equation times negative 3. When I do that, I get negative 3x plus 6y equals negative 15. That top equation, I'm not going to change it at all. I'm just going to write it down. 3x plus 4z equals negative 11. Now when I add those together, I have a 3x and a minus 3x gives me 0 x's. Don't accidentally add your y's and z's together. They're different terms. You can't combine them. All we can do is write them down together. Okay? So I'm going to have a positive 6y and a positive 4z is going to be equal to negative 26. Now I have two equations with just y and z in them, and I can use that to solve. Okay, so I have 6y plus 4z equals negative 26, and 4y minus z equals negative 10. I want to eliminate a variable. It looks like z would be the easiest one to eliminate because I can just multiply this bottom one times a 4, and I'll have a positive 4 on top, negative 4 down here. So that's what I'm going to do. Take this bottom equation times 4, and I will get 16y minus 4z equals negative 4. My top equation is not going to change. We add them, and we notice the z's cancel just like we wanted. We get 0 z's. For my y's, I get 6 and 16, gives me a 22y, and negative 26 plus negative 4 . Oh dear, sorry about that. Go back here. This was a 10, negative 10, which was making this a 40. I'm like, that's not working out like I wanted it to. Sorry about that. We have a 40 here. Negative 26 and negative 40 is negative 66. If you're wondering what in the world, I apologize. I fixed that for you. And our last step is to divide both sides by 22. So I get that y is negative 3. There's one of my variables. Now I'm going to have to go back and find the other two. Well, let's use this equation here to find our z. So we know 6y plus 4z equals negative 26. Okay. We know y is negative. So now we have that 6y plus 6 times negative 3 plus 4z. Make that a little neater. And I get negative 18 plus 4z equals negative 26. Add 18 to both sides. And we get 4z equals negative 8. So our z is negative 2. Okay, so we have y, we have z. Now all we have to find is our x. So we're going to go back to either of these equations. As long as they have an x value in them, that will work for us. So if we use that top one, it has an x in it. 3x plus 4z equals negative 11. Our z we found was negative 2, so we can substitute that in and have 4 times negative 2. That gives us 3x minus 8 equals negative 11. Add 8 to both sides. We get 3x equals negative 3, or x equals negative 1. We're done with that one. We found our solution to be negative 1, negative 2, negative 3, negative 2, x, y, and z. Okay, we have one more problem we're going to go through here. It's a shorter one, and it's an important one, so stick around. Okay, so here is our last example we're going to do here. And again, what we want to do in these types of problems is we want to get two equations with just two variables in them. Notice we have one down here that has x and z, and our second equation just has y and z. So again, we want to make a choice. We need to somehow eliminate either an x or a z so that we can solve this problem. So let's say this time I chose to eliminate the y, so that I just had x's and z's. Well, if I take this first equation, I have a negative y. The second equation has a positive 2. So if I take the top equation times 2, that will give me a negative 2y here, positive 2y there, and they will cancel. So there's my plan. Let's go ahead and carry that plan out. Okay, I'm going to take the top equation times negative 2, and that will give me negative 8x. Or not negative 2, good laws. It's getting rough at the end, isn't it? Me 8x minus 2y plus 2z equals 10. I add that to the second equation, which was just 2y plus 6z equals 30. My y's cancel when I add those together, and I get 8x plus 8z equals 40. Now we have two equations with two variables because this third equation here just had x and z. Okay? So here is the equations we have. We have 8x plus 8z equals 40 and x plus z equals 6. We want to eliminate a variable. Let's say I choose to eliminate x. Okay, I have an 8x here. I need a negative 8x in the other. So I'm going to take this second equation times negative 8. That gives me negative 8x minus 8z equals negative 48. My top equation that I had there, I'm not going to change that. Just 8x plus 8z equals 40. But notice something weird happens here. When I add these together, my x's cancel, get 0x. My z's cancel, I get 0 z's. So I just have 0 on the left-hand side. On the right-hand side, I get 40 minus 48 is negative 8. 0 equals negative 8 is not true. Therefore, my answer here is no solution. Anytime all of your variables cancel and you get a number equal to something it's not equal to, like 1 equals 5, 3 equals 8, in this case 0 equals negative 8, your answer is no solution.